Welcome to BAS 121. We're on Chapter 11. We're talking about adding risk and uncertainty to models. So we're going to go back to our pharmaceutical model, more pharmaceuticals, where we were looking at a discussion of is it worth making an investment of roughly $850 million in new product development, and we had a market size of about 2 million. We were told our monthly revenues were $130. Our monthly costs were 40. We used a discount rate to calculate our net present value of 9%. Our original case R&D costs were $750 million, and clinical trials, I think I've changed it a little bit to put some distribution here. I think the original was around 75 million. So here we have 825 million in upfront costs, and then the model that we created has a market growth factor, a market size, and then that's growing at these growth factors. What our market share growth is, we assumed our original market share was 8%, and it would grow at about 20 per year. And this gave us what our sales in units were. The market size multiplied by our percentage market share gave us the number of units of sales we would have. And then our annual revenues were simply taking the unit sales times the monthly revenue we got from each unit multiplied by 12 because there's 12 months. We did similar exercise for the cost. Same thing except we multiplied by the monthly costs. Of course, our profits were nothing more than our revenue minus our costs. And then we calculated a cumulative net profit down here by adding in our one-time investment of $850 million. And we cumulated them across here. And of course, we calculated our net present value by taking our 5 profit inflows and discounting them at the 9% discount rate, and then subtracting our one-time investment cost. And I think in the original case, we had a net present value of about $185 million. But what if the boss said, there's an awful lot of uncertainty in this model. There's uncertainty around the market size. There's uncertainty around our R&D costs. There's uncertainty around the market share growth rate. There's uncertainty around what our market share growth rate's going to be. So to understand these better, we can take our model and we can add some uncertainty to them. So I've done these bottom 3. Let me show you a couple how we would do that. So if we want to add to the market size, we would go to our analytic solver. We would say distribution. And for this one, let's put in a normal distribution. It's going to ask us for what the mean is. Well, let's say the mean is 2 million. And a standard deviation around that of 400,000. Excuse me. Okay. Let's put a distribution around our R&D costs, and let's make this one be a uniform distribution. And let's make it be a range from 600 million to 800 million. We know our R&D costs are going to be somewhere in that range. I got to make sure I put in the right number of zeros. 800. Okay. Now these other ones I had already done previously. So I'd put a distribution in here. You can see if I put the log normal distribution in there. I put a triangular distribution in for our market growth factor. I put another triangular distribution in for our market share. And you can see these all pop up. And if you want to see them, you can click there. That one pops up. That one pops up, our log normal. You can see it's not a normal distribution. It's got a little bit of logarithm built in there. So what we've done now is we've made these 5 different variables uncertain. We've put uncertainty in around our market share, uncertainty around our R&D costs, around our clinical trial costs, uncertainty around our market growth, how big the market's going to grow, and then we put uncertainty around how much we think our market share is going to grow, which is probably more realistic, right? So now that we've defined our uncertain variables, the next thing we have to do in the model is define what our output is we want it to be. Well, we want our output to be this cumulative net profit, and then I'm going to hit the control key, and our net present value. So we're going to say results, output, in cells, those 7 in cells we want to be. So now we've defined our uncertain variables, we've defined our output, now we just have to define what options we want. So we can come up here and say, let's look at all options. Well, we're going to run 10,000 trials, 1 simulation 1. We want a Monte Carlo simulation, so we're good to go. So now we're ready to run a simulation. So let's run 1 simulation and see what we get. Okay. Now, we can go down to our net. Now, we've got a couple of questions here that they want answered. What is the risk that the net present value will not be positive? Well, let's go to this cell. And we can click to see. Well, I think I've run this. The likelihood, we have an upper cutoff. You can see the likelihood that we make money is about 80%. The likelihood that we won't make money is 20%. Now, some of you are probably saying, wait a minute. The book has an answer that says it's 82% chance that we make money and only an 18% chance that the net present value is 0 after 5 years. Well, we got the wrong answer. Well, not really. When every time you run 10,000 trials or run a simulation, you're going to get slightly different results. So, I wrote, this gives us a lot of information. It gives you the mean, the standard deviation, which we're going to use in a few minutes to calculate a confidence interval. Right? How confident are we around that 185 number for a net present value? So that answered the first question. There's about an 80% there's about an 80% chance that we're going to have a net present value that's positive, about a 20% chance that we'll have a net present value that's not positive. Let's minimize that. Let's go to the next question. What are the chances that we'll show profit after the 3rd year? Well, let's go up to the 3rd year. Let's double click. All right. The probability that we'll show profit after the 3rd year is about 9%, right? The reason I got this color coding is I put my lower cutoff at 0. So about a 9% chance that we'll be profitable after 3 years, about a 91% chance that we will not be profitable. So we can say to the boss a couple things. You know, we think we ran 10,000 simulations. The mean's about $185 million net present value over 5 years. You know, we're not going to be profitable. It's very unlikely we're going to recoup our money after 3 years, because we see right here 91% chance that we haven't become profitable on a net present value basis after 3 years. But we're about 80% confident that after 5 years we'll show a positive net present value. It brings to me a little higher level analysis when you can add this sensitivity into it. So what's the probability? What is our probable earnings at a 90% confidence interval? Is the next question in the book. Well, let's go to the 5 years and let's see here, and we can go over here. It says statistics, but right down here it tells us percentiles. So we can click on that. So we're 90% confident that we will lose 96 million or better. So there's a 10% chance we're going to lose money. We're not 100% sure, but we're 90% confident we won't lose more than 96 million. Pretty big stakes, right? I mean, remember, we're investing 185 million. Now, again, this answer is a little different than what the book is, because every time you run 10,000 simulations, you're going to get a slightly different answer. But also notice our answers, they got 18%, we got 20. They got 8%, we got 8%. They're very similar, but they won't be exact because you're running different trials. So we've answered these three questions. What is the risk of the net present value? The book said 18. I think we got 20. The profitable after 3 years, I think we got 8 or 9. They got 8 or 9. The only big difference that we got was they got a 90% chance that they would make 180. We got quite a bit lower, in part because look what happened with our simulation. We got a very low market size on when we ran our simulation. So then, what's the confidence interval? Well, if you remember back to last chapters, I took the mean that it gave us. I took the standard deviation. We know the number of trials. We can look up in Excel the 95% confidence interval on a two-tailed test is a z-score of 1.96. So we calculated the range with our old formula. Remember, multiple trials. It's our mean, our z-score times our mean divided by the square root of the number of trials. That gave us a low range and a high range. So now, what if we wanted some sensitivity around these numbers? Well, we could go back up here, and we could click on this, and we could say, give me the sensitivity. Now, what the sensitivity is going to tell us, it's going to tell us a couple things that are relatively important. In fact, very important as we try to refine this model. It's going to tell us net present value, which one of these factors, which one of these uncertain variables is going to impact our net present value the most. So this is a correlation, and to the right, the blue is a positive correlation. So if you remember, is market. So B5 was market size. As market size increases, our net present value increases, and it's the most highly correlated factor there is. That's why so that's the most critical thing. So a couple things you might want to do. You might want to spend your research time to improve your model to get a better understanding of what that market size is, because that's the most critical thing to our forecast. The second most critical thing to our forecast, which is negatively correlated with net present value, is what is our R&D cost going to be? So again, we might want to really ask some questions of the R&D department. How sure of you of that R&D cost being $750 million? How confident are you in that number? Now, this also tells us some of these other factors aren't nearly as important or as nearly critical to the outcome of net present value. So we might go back and simplify our model and say, we can put in fixed values for those. Maybe we don't have to make them uncertain values. So you go through this iterative process of building your model to make it better and better and better each time as you understand better what's going on. And this gives, to me, a tremendous wealth to convey to management for decisions other than just, we ran the net present value and it was $185 million. Now you're giving them a lot more information around the risks that they're going to take and the simulations that they're going to take. Now, one other thing we can do, we can go up to these charts and we can go to a trend and we could say, here's the trend over the 5 years of the year 1, year 2, year 3, year 4. Here's where we expect to be by year, and here's the range. Here's where we're 75% confident. Here's where we're 90% confident. And this gives us what it is over the 5 years. So we see right here on this chart, we can say to management, well, let's look at what we think the absolute prediction is, but more importantly, What is the band that we're 75% confident in, and what is the band that we're 90% confident in? Another report management might be very interested in is another chart, is this box whisker chart. This gives us the mean and the range, intervals between the range of our net present value. And not surprisingly, as we go out each year, our range becomes much larger, right? Because there's more risk. It's easier to forecast the first year than the fifth year. So this gives you about what we project for year 5 and what that range is in terms of a 75% confidence interval, and I think this is a 95% confident interval. So lots of reports that you can get that convey a lot of meaningful information around all this stuff. So we've shown you the trends, the box whisper. We've shown you how to get sensitivity tabs. We've shown you how to calculate the confidence interval around these things, answering some questions. Any questions? Let me know. Thanks.